Alright, ladies and gentlemen, this lecture is about surface water, specifically with river systems. Take notes as needed, pause, and go back as needed as well. Let's get started. River systems form usually when the precipitation, what's falling out of the sky, will exceed the evapotranspiration rate. And evaporation, that's water, liquid water going to a gas, and transpiration coming from green plants. The conditions must be conducive to water running off the soil instead of sinking in. So we want the water to not just go into the soil, into the groundwater, but mainly into a river or a valley. The runoff is simply what it sounds like: water flowing down slope along an earth's surface, off the surface into a body of water. Several factors to consider are the vegetation. The more vegetation, the less runoff you'll have. The composition of the soil, the rate of precipitation. So the more precipitation you have, the greater the amount of runoff, and the gradient. The higher the gradient, the higher the runoff. River systems consist of three different things. Tributaries are those small little creeks that feed into a larger river. For example, Crabtree Creek is a tributary of the Neuse River. The watershed is a much larger area that encompasses all the land and tributaries of a main river. And you can have watersheds of smaller rivers, like there is a Crabtree Creek watershed along with the Neuse River watershed. And they're also called river basins as well. Divides are high areas that divide watersheds from another watershed. Tributaries, like I mentioned, are feeder streams that feed larger bodies of water. The picture to the right is of Pamlico Sound, and the two main tributaries are the Tar River and the Neuse River. In North Carolina, there are a bunch of different river basins, or watersheds. Part of the rubric for this project is to do research on a watershed, and you guys later on will be choosing one of these watersheds to do research. But it's all the land area where the water drains into a stream. And for more information, you can click on or go to that link, and it'll give you more information about the watersheds in North Carolina. A divide, the highland area that separates one watershed from another. The continental divide, one of the biggest examples in North America, separates everything that flows into the Mississippi River from everything that flows into the Pacific Ocean. You can look that up on Google. Just Google continental divide, and it can show you a map of where that is. Stream load is all the material carried by a stream, like all living components like fish and organisms, to the sediments, any dissolved solids, any dissolved gases like dissolved oxygen. And we need more dissolved oxygen. The higher dissolved oxygen you have, the greater amount of sea life you have, or not sea life, river life. A couple things with how things are carried by by the streams. Solutions are always going to be dissolved. You don't want a lot of solid particles flowing through the river. Suspensions, anything that's suspended within the river itself, that's not really on the bottom or floating on the surface, but it's inside the river. And the bed load, either they're rolling around the bottom of it. Traction is the pushing, rolling, or sliding a load along the bottom of the channel. And saltation is bouncing. You can have saltation in a fluid, and when we talk about oceans, we'll talk more about saltation as well. Velocity is affected by the slope of the river channel, the depth, width, and friction. And we'll be doing some more calculations. We'll calculate discharge, which definition is the volume of water that flows by a location in a given period of time. And you can calculate that by multiplying the width, depth, and the velocity. Carrying capacity is the ability of a stream to transport material. It depends on the velocity and volume of water. So the higher the velocity, the more water there is, the more stuff you're going to be able to carry in the river. And it's affected by, again, the slope, depth, width, and the friction in the river. Example is the Amazon River. In one 24-hour time period, one day, the amount of water flowing through the Amazon River is enough water to supply New York City for about 9 years. floodplain is the area surrounding a river or stream that is periodically flooded. Usually the insurance rates for homes are higher in flood streams, and I would highly recommend you do not live in a flood zone. Floodplains are flat for a reason. They're used to fill up when the river floods. Picture on the right is a typical river valley or floodplain with the river and the valley on either side, with river channels and tributaries. The bedrock's on the bottom with sediment like sand, gravel, and clay at the bottom of the river. You have the divide on either side, and the floodplain there as well. Streams develop over a long period of time. Youthful streams have V-shaped valleys. Usually when you have rapids in a river, that's an indication of a flat river, or not a flat river, a youthful river. A mature stream will have the floodplain with divides on either side. An older river will have a wider floodplain with cutoffs and oxbow lakes, pictured there in the bottom left. Rejuvenation is the downcutting in the areas of mountain, usually in areas of mountain building. It helps to regenerate the river. Again, the river will always be cutting a V-shaped channel inside the mountain. In meanders, or how the river flows and bends, on the outside of the meanders where you're going to have the highest flow of water. The inside of the bend, that's where you're going to have all the deposits. In the picture on the right, you have a point bar. That's where all the sand and silt and clay is being deposited on the inside of the meander. That'll create a neck. And occasionally you'll have a cutoff. They're pictured and pointed off in red. And then there's an oxbow lake. That's an old river channel that's been cut off from the main river flow. If you fly over any part of the United States, over an old river, you can see a lot of these kind of oxbow lakes pretty much everywhere you go. Deltas, that's where rivers will meet up with the ocean or lakes. Examples are the Alaska and the Kenai River Delta. The delta is usually triangle-shaped. Deposits where moving water enters a body of still water. Picture on the right, that's the Mississippi River Delta in extreme southeast Louisiana. These are always changing. In Louisiana, hurricanes will change the shape of the river delta. Another good example is the Nile River. If you go on Google Earth, and go to the Nile, top part of the Nile, it flows north into the Mediterranean. The Nile River Delta is almost a perfect triangle. It's a green triangle in a sea of desert. And finally, alluvial fans will form when you have the river flowing out of a mountain into a valley. And that alluvial fan is a bunch of sediment being deposited from the river that's slowing down. And it's usually in a fan-shaped, spreading outward from a river. That's rivers. Repeat this video if you need to. Email me with questions. You have a quiz the next day. Thank you.